Hello everyone, I'm Paul and today we're solving problem 1716, calculate money in Leetcode bank. This is easy, so here I will show you what's my thought process and efficient solution. The description is simple, we need to put money in the bank. So first we put $1 on Monday, and every day from Tuesday to Sunday we put $1 more than the previous day. So here in Tuesday, we put 1 plus $1, meaning 2. Here we put 3, here 4, 5, 6, and 7 on Sunday. Now, on every subsequent Monday, we put $1 more than the previous Monday. So, after Sunday, we reach Monday again, and we take the value for the previous Monday plus 1. So here we put 2. And we repeat the same process. So, the next Tuesday, we take this number plus 1, meaning 3. And on Wednesday, we have 4, 5, 6, 7, 8. Okay? Now, our job is down here. We are given an integer n, and we need to return the total amount of money that we will have in the bank at the end of the nth day. So, if n is 4, we need to return the total amount of money up to this point, meaning 1 plus 2 plus 3 plus 4. And this is 10. So we return 10. For example, if n is 2, we need to return the amount of money up to this point. So 1 plus 2. We return 3 in this case. And the key to solve this is down here in the constraints. We know that n is smaller or equal to 1000. This means that we can replicate this exact simulation in code. We can have an array where each element corresponds to the amount of money for each day. First we have 1, then 2, then 3, 4, 5, 6, 7, and so on. And this is index 0, this is 1, 2, 3, and so on. Now at this point we are at index 7. And when we reach an index for which when we do this modulo 7 the result is 0, this means we are standing at Monday. And whenever we reach this point, instead of taking the previous value plus 1, we take the current index minus 7, meaning the previous Monday, plus 1. That's why here we have a 2. And then we continue with the same process. Here we are at index 8, so we take the value for the previous index plus 1, and here we do the same, 9, 10, 11, and n is smaller or equal to 1000, so we can build this same array with 1000 elements and use this array, pre-compute this array for every test case. And let's say n is 4, well, we take the sum for every element in the array from index 0 to index n minus 1, meaning 3. And 1 plus 2 plus 3 plus 4 is 10, so we return 10 in this case. And so on. Once we pre-compute this for 1000 elements, we are good to go for every test case. So with this in mind, let's go with the code. First, we need to pre-compute the array for every test case. So we go up here and say array is an array with 1. And for I in range from 1 to 1001. And now we're checking if we are standing at Monday, meaning if I modulo 7 is 0, current is array at minus 7 plus 1. Else, current is the previous day, array minus 1 plus 1. And now every time array.append this day, meaning current. And now with this array, every time we can just return the sum of array, and here we take a sub-array from the start to n minus 1, and this part is non-inclusive, so here we just put n. This is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. This part up here technically requires a time and space complexity of big O of 1 because we go from 1 to 1000, and this part requires big O of n time and space complexity. Now I'm sure you can solve this with math in big O of 1 time and space, but I think this solution is overall more intuitive. So this is it for this problem. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.